record-breaking cyclone activity, explosive volcanic eruptions, powerful earthquakes, and endless heat waves. 2015 was marked by a number of exceptional natural disasters. The toll of these terrifying events, 20,000 lives lost, and more than $42 billion worth of damage. 2015 was a record-breaking year in several categories. Tropical storms of unprecedented strength, interminable droughts, and the highest temperatures measured in the last 130 years. Is this the result of global warming, or could other factors, such as El Nino, be to blame? How do scientists try to forecast these cataclysms? Is it possible for inhabitants to anticipate and prepare for these natural events? From the mountain range of the Andes to the Himalayan plateaus, past the frozen wastelands of Iceland and the paradise islands of Vanuatu, scientists try to unravel the mysteries of the planet's mood swings. Using only professionally shot footage, capturing the heart of the action, this film presents the major natural disasters of 2015, from the least deadly to the most dramatic. Typhoon Dejuan was emblematic of natural disasters for 2015, which hit Taiwan in September. 500 millimeters of rain, the equivalent of 4 months of precipitation, fell within 24 hours. Taiwan sits directly in the Pacific cyclone path, and the Taiwanese government is used to warning the population to stay indoors and evacuating areas that are most at risk. According to Fabrice Chauvin, cyclone specialist at Météo France, the official French weather forecaster, the island of Taiwan is closely monitored by the scientific community.
Taiwan is in a zone that is often hit by cyclones. The west of the North Pacific is the zone that has the most tropical cyclones. Out of all the cyclones, they receive about 60% of the year's cyclones.
The impact of the storm was particularly visible on the coast. The shoreline was devastated by huge waves that were the result of two events, the typhoon itself and the closeness of the Earth to the moon, which generated a storm surge.
The level of the sea rises because of the depression caused by the cyclone. Because there is less pressure on the sea finds its balance a bit higher than normal. So we have a rise in sea level.
In response to the emergency, the floodgates of dams were opened to compensate for the sudden influx of rainwater. This huge rainfall is due to surface sea temperatures being abnormally warm. This stimulates the number and intensity of North Pacific cyclones. A total of 29 have had wind speeds higher than 180 kilometers per hour in 2015. This unusual activity sets a record for the year to date. So many cyclones raged over the Pacific Ocean that this film shows a mere sample of these extreme weather events. Another island, another threat. A desert of rock and ice, one of the most hostile and mysterious areas of our planet, Iceland. Nestled against this backdrop of fairy tales and Nordic legends, the largest glacier in Europe shows signs of unusual activity.
The activity started with a seismic swarm under the whole part of the northwestern area of the Vatnajökull glacier. Nobody knew what was going on. It was a very big event.
Olgeir Sigmarsson is originally from Iceland, but has been working in France for the past 20 years. He studies the origin of magma using its radionuclear composition. Iceland is a highly active volcanic area. The island is situated just above a hotspot, an area where magma rises from the depths of the Earth up to the surface. Iceland is also located in an area where two continental shelves pull away from one another, allowing magma to rise up and create a ridge under the ocean. The scientific community keeps a close eye on this area, alert to any sign of potential eruptions. And yet, hidden under this giant glacier is one of Iceland's biggest yet little-known volcanoes, Bardarbunga.
It is very famous if you ask an Icelander. Elsewhere, maybe it's not so well known because it hasn't been active for several decades or centuries. The last eruption, a small eruption, occurred in 1903, but before that, the last large eruption was in the 15th century.
Bardarbunga is unusual because its main crater is entirely hidden under ice. So there's no way of observing anything erupting from it. Yet Icelandic scientists have managed to map the concealed ground and discover the appearance of Bardarbunga, a huge collapsed crater or caldera whose rim rises 400 meters above the bottom of the crater. And on top of that, 800 meters of ice, the perfect recipe for disaster.
If an eruption would have occurred in Bardarbunga itself, it would have melted the ice, and with 800 meters thick ice, it would have created catastrophic floods that would have flown both to the north and potentially to the south, which is more dangerous in the sense that there are hydropower stations in the rivers that come from the glacier, and the villages are not far away south on the way to the sea.
Fortunately, Bardarbunga is located in a sparsely populated area, and access roads were closed early on, allowing only scientists to get close. The nearest inhabitants are used to the land's lively temperament, and in a worst-case scenario, are prepared to live self-sufficiently.
A possible eruption, I'm not very scared of it. We're quite safe here for a quite long time. We are living in a country that is forming, and just get used to what is happening and how it is forming. It could happen in 10 years or tomorrow, we never know.
On this relatively flat land, the real danger comes from potential flooding. Water flowing at high speeds over a vast area could cause massive damage.
We are here at the road number 1 in Iceland, which connected the north side of the country and the east side of the country. And if they lose the bridge, we have to drive about 1,400 kilometers instead of maybe 30. So we will do everything we can to save the bridge. You have to wait and see. Hopefully there will be no flood, but we don't know.
After several days of anxiety, the eruption under the glacier fails to occur. Instead, the magma seems to escape sideways, finding its way to the surface away from the glacier. The Earth's crust cracks and opens to the north of the huge white ice field, allowing magma to burst dramatically into the open air.
The activity concentrated in one part and formed a large crater that was approximately half a kilometer long, in which there were 3 parts, very active, but a magma or lava lake inside this crater, which then flowed into the rivers and fed the lava field itself.
At this stage of the eruption, scientists are only partially reassured. Though the risks of the glacier collapsing and causing huge flooding seems to have been averted, nobody knows what might happen next. Lava continues to spill out of the volcanic fissure at 300 cubic meters per second, a massive flow that spreads out in all directions. Under the watchful eye of the scientists, a new phenomenon develops. Above the volcano, the glacier seems to be sinking, yet there is no sign of melting. This could explain why the worst possible eruption scenario has been avoided.
Some would say that the sinking of the block above a magma chamber might push out the magma from a magma chamber, possibly in a lateral manner. Others would say that by taking the magma out through the fissure, it lowers the pressure in a potential magma chamber beneath the center of the volcano, so it will sink. But this is a bit like an egg in the hen problem.
In February, the eruption comes to an end. The pressure in the volcano seems to have dropped, and the magma is no longer pushed to the surface. In total, Bardarbunga spewed lava over 85 square kilometers, enough to submerge Miami under 3 meters of lava. A large eruption, but considerably smaller than that of its historic activity.
1.5 cubic kilometers, which is quite large. Then in the past, I mentioned the big one, 25 cubic kilometers. That is 8,400 years ago, close to the deglaciation. And closer to us in time, there seems to be smaller and smaller volume of magma coming up in each eruption.
Could there be a mysterious link between deglaciation and volcanic and seismic activity? Robert Muir-Wood is a specialist in earth sciences who has been researching this connection.
We had a huge ice cap over northern Europe, which was about 3 kilometers thick. Those ice sheets, they weighed down on the crust of the Earth. They were a huge load appeared, and they caused the crust of the Earth to sink. Now, when you take away the ice sheet, you switch around the situation. The area which had the big weight on it goes up, the area around it comes down. And these processes last for thousands of years. The land is still recovering today.
The scars left by these deformations are sometimes still visible. The Earth has risen dozens of meters around these ancient ice caps. Luckily, this post-glacial rebound no longer has the same devastating effects as before.
The big deglaciation happened about 15,000 years ago. So if you were asking me this question 15,000 years ago, then I think we would be witnessing big earthquakes, big volcanic eruptions, and we could say this is because of the melting of the ice sheets. We're getting a lot of these catastrophes. I think there was something like 10 huge ice caps which existed 20,000 years ago around the northern hemisphere, and today there's only one, and that one is in Greenland. Even if the Greenland ice sheet starts melting really fast, and we start having more earthquakes in the vicinity of Greenland, it won't have a very big impact.
The amount of magma spilling from Bardarbunga could be less than in the past, but it's impossible to draw any more conclusions for the future.
The link would be that there was so much magma generated at the very end of the glaciation, and there is less and less magma being generated because the crust is still recovering from the large glacier 10,000 years ago. Nobody is going to say that the eruption in the future will be smaller or bigger because nobody knows. It's only guesses.
Despite the dramatic cascades of lava, the eruption of Bardarbunga was a natural event causing little damage and no victims. And to continue this series of non-threatening incidents, we head to another eruption that, as a result of its location, could have been disastrous. Far from Iceland, at the southern end of the Japanese archipelago, the Sakurajima volcano shows signs of awakening. Explosions, plumes of smoke and ash. This volcano, located on a peninsula occupied by 4,000 people, is one of the most active in Japan, with between 500 and 1,000 small eruptions each year. Concern is that the Sendai nuclear power plant, located just 50 kilometers away, has recently powered up again 4 years after the Fukushima disaster, when all of Japan's nuclear power plants were shut down. The state of alert has been raised to level 4, preparing the population for imminent evacuation. After several weeks of suspense, the Japanese volcano appears to calm down, its main crater gradually blocking up with a plug of lava. Once again, no victims and no damage, at least for the moment. Nonetheless, Japanese volcanologists will be keeping a close eye on Sakurajima and the nuclear power plant over the next few years. In South America, another eruption demonstrates what might have happened. It's 6 p.m., the end of the day in the tourist region of the Great Lakes, 50 kilometers from the town of Puerto Montt. In this peaceful area, residents suddenly hear sounds coming from underground. A mysterious rumbling rolls over the foothills of the Andes. No other warning, no other signs of alarm. Just 15 minutes after the first sounds are heard, the Calbuco volcano, dormant for 4 decades, sends a plume of thick smoke into the air.
There was very little precursory activity at Calbuco. The Chilean had a station close by, and just 1 hour before the eruption, they observed a signal that was interpreted to detect a magma coming up through the volcano.
The entire Andes mountain range is a highly active volcanic area. It's in a subduction zone, where one continental plate is forced under another.
When the subduction zone is going down, it goes through transformation, and all the seawater is pressed out, will enter into the mantle and lower the solidus, so the magma comes up.
This column of ash is a result of high-pressure gases trapped in the magma inside the volcano's reservoir. As the gases are forced out, they lose pressure and swell, taking with them small particles of lava. The plume is unusually high, rising 20 kilometers above the surface of the Earth, between the troposphere and the stratosphere. If the column of ash were to collapse onto the town of Puerto Montt and its 220,000 inhabitants, the results would be devastating.
You have a thrust coming up, and it's diluted in contact with the atmosphere, so you form a kind of a mushroom shape on the top. And when this is no longer sustainable, it will fall down, and you can form a pyroclastic flows that will fill the lows, the valleys, etc., and can flow very hot material and be very devastating.
Fortunately, the wind from the Pacific picks up, pushing the plume to the east where the mountains are unpopulated. The ash spreads to Argentina, where the authorities are forced to close the airspace. The ash is a dire threat to aircraft engines.
Very small particles, less than 10 micrometer in size, are not very healthy to breathe, because they have sharp edges and they can cut a little bit of your interior.
Puerto Montt is spared, for the moment. As a precaution, a 20-kilometer zone around the volcano is evacuated. After a period of calm, as night falls, there is a second explosion. The eruption enters a new phase, with electrostatic charges or volcanic lightning bolts exploding above Calbuco's crater.
Afterwards, there were bolts of lightning. They were really low. It was an incredible cloud. We could see it in the middle of the night. pero muy cerca.
Really close by.
Un arenal con
A cloud of sand arrived. It was very
pero
thick.
que pensamos que
We thought
era
it was
como
hailstones
granizo.
falling. Though the eruption lasts 3 days and nights, no human lives are lost. The surrounding countryside, however, is destroyed. 210 million cubic meters of ash smother houses, forests, rivers, and plains.
Al día siguiente, fui uno de los primeros que vine a la zona para ver cómo estaba.
The next day, I was one of the first to arrive in the area to see what it was like. And I found the restaurant like this, completely flattened. The entire restaurant is lost. I was born here and grew up here, and I would like to keep working here. It's just an accident of nature. Could happen here or anywhere. It's destiny.
Our garage collapsed, and the roof of an older house broke and twisted. We tried in vain to get fuel and food for the dogs because we didn't bring anything with us. And we only managed to get back into our house the next day to see what damage had been done.
The lava ejected from the volcano caused little remaining damage within the 5-kilometer perimeter. The real threat came from the tons of ash that accumulated on the roofs of buildings, which could have collapsed at any moment. 6,000 people were evacuated in order to avoid the risk of being trapped.
Here, there is about a meter of ash that has fallen. That's what we're trying to remove at the moment. This is also a tourist area, so there will be an economic impact. Regarding the farms, it looks like the ash will be a major problem for the livestock.
You may have volcanic gases coming along if they are very rich in fluorine, and this fluorine can stick to the surface of the ash grains. And if the animals eat a lot of the fluorine, they will lose their teeth and their bones.
But the main thing is the roofs of houses collapsing and pollution of water sources.
Not a drop of drinking water remains. Ash and sulfur contaminate all the rivers. In some areas, the layer of volcanic debris is so thick that the water is no longer even visible.
We have 4 days until Wednesday, when it is due to rain. So we need to have finished the houses that are in this state before then.
Rain is not to be taken lightly in this area of Chile, where clouds loaded with water from the Pacific Ocean are blocked by the Andes and release their charge in violent storms, causing landslides of mud and ash. Several months after the events, with the benefit of hindsight, volcanologists play down the effects of the Calbuco eruption.
Then there was a small eruption, well, important for those living close to the volcano, but small. The volume is being estimated. Maybe it's around 0.1 cubic kilometers, not much more than that, I presume.
Although the Chilean volcano took no human lives, it nevertheless caused $600 million of damage. The calamity that spared the Chileans hit the residents of another volcanic area. 5 years ago, after 400 years of inactivity, the Cabong volcano awoke. Since then, its eruptions have been both regular and dramatic. The last one took place in June 2015. Usually, Sinabung's lava is thick and flows slowly. But this time, the volcano generated impressive pyroclastic flows. These are thick clouds of ash and lava particles that rise up and then collapse under their own weight, sweeping down the flanks of the volcano. 11,000 people were evacuated and moved this year. A catastrophe for the farmers who could no longer access their land and resources for several months. Even though the volcano appeared to be calm, one person was killed when he breached the restricted area. Pyroclastic flows are difficult to predict and can extend up to 4 kilometers around the crater with a cost of $145 million in agricultural damages. Natural disasters can appear from above as well as below. Weather events were among the most devastating this year in terms of victims and damage. It may not have been the most impressive natural disaster of 2015, but it was certainly one of the most expensive in terms of damage. Huge snowstorms hit the northeast coast of the United States and Canada, causing $3 billion worth of damage. Yet only one person died as a result of a sledding accident. Traffic came to a standstill. Economic activity was frozen. Roofs collapsed, and ice caused injuries and accidents. Insurance companies paid out $2.5 billion as a result of snowstorms that lasted several weeks. More than 3 meters of snow fell in New York and around Boston, covering the towns and their inhabitants under a thick white blanket. Less poetic and considerably more frightening, the 2015 cyclone season was particularly brutal in the Pacific. The main culprit is the return of El Nino, a weather phenomenon that appears on average every 3 to 7 years. El Nino is carefully monitored by long-term forecasters like Jacques Richon, who works on the 3-month forecast of Météo France.
Il s'agit d'une anomalie de la température de surface de l'océan dans le Pacifique. Habituellement, c'est ce qu'on voit sur ce schéma. Les vents dominants sur le Pacifique sont des alizés qui poussent les eaux de surface les plus chaudes vers l'ouest. Puis la situation El Nino, où on voit que les zones en rouge se sont décalées vers le centre et l'est du Pacifique. Donc les températures les plus chaudes, autour de 26 à 30 degrés, se retrouvent maintenant beaucoup plus à l'est. La contrepartie côté atmosphère, c'est qu'au-dessus de ces eaux les plus chaudes, il y a aussi les orages les plus violents. La convection, donc les mouvements verticaux les plus forts, et les précipitations les plus fortes.
Not all El Nino events are alike, and this year, a particularly strong effect has been announced.
On est parti pour avoir un El Nino fort.
We're heading for another strong El Nino, one of the strongest in the last 50 years.
On ne sait pas encore si ça va être le record le plus fort, mais en tout cas, on a un El Nino qui est vraiment fort cette année.
Un El Niño, on va dire classique,
a classic El Nino won't raise the temperature more than 1.5 degrees. The 97-98 El Nino rose to 2.3 or 2.5 degrees, depending on the area. Today, we are at 2 degrees, and we haven't yet reached the maximum.
The result is an exceptional cyclone season in the Pacific. Whether hurricanes, cyclones, or typhoons, the names change depending on where they take place. These spiraling storms have beaten several records in 2015.
In tropical storms, as soon as the wind speed is higher than 120 kilometers an hour, 74 miles an hour, they are categorized as cyclones. Below that is a tropical storm, and below that is a tropical depression. So in general, we take the forecast into account once it goes above tropical depression. We start to be very vigilant, and when it reaches tropical storm speed at 60 kilometers an hour, 37 miles an hour, we give it a name which allows us to follow it more easily.
El Nino is characterized by an abnormal rise in the temperature of the surface of the water in the East Pacific Ocean, a vital factor in the formation of one of the most sensational events of 2015, Hurricane Patricia. In October, the effects of El Nino began to make themselves felt. According to Eric Giliardi, climatologist and specialist of the Pacific Ocean, the water was warmer than is normal at this time of the year by 2 degrees Celsius.
This is a zone where there are some cyclones, but not very strong, and they certainly don't develop to the same size as Patricia. Patricia is directly linked to the fact that we have an El Nino at the moment. The fact that the water is warm in the east and stays warm is a source of energy for the hurricane, allowing it to develop. The source, the seeds of a hurricane, are always there, but the fact that it develops into a real hurricane of the size of Patricia is linked to atmospheric and oceanic conditions that are conducive to development.
With these unusual conditions, a remarkable phenomenon occurs. Hurricane Patricia rapidly intensifies. In only 24 hours, it morphs from a tropical storm to a Category 5 hurricane.
Theoretically, any hurricane could grow to maximum strength, like Hurricane Patricia. But in general, with hurricanes, there are other factors which will limit its amplification. The water gets a bit colder, it reaches a landmass, or there are high-altitude winds that destabilize the hurricane. When we look at the particular conditions of this hurricane, it really grew. There was nothing to prevent it from building to its theoretical maximum intensity.
On October 23rd, Hurricane Patricia slammed into Central America, breaking the wind speed record for the North Pacific with an incredible 265 kilometers per hour. The violence of the storm caused multiple casualties. 12 people died in landslides caused by torrential rain or by falling trees. Luckily, the hurricane's path missed the largest cities on the Mexican coast. The authorities had safety measures in place prepared to house 260,000 people, but ultimately only 50,000 were evacuated. Hurricane Patricia headed inland towards the mountains, rapidly losing power. The total cost of the damages was estimated at $5 billion. The economic evaluation of natural disasters varies depending upon the countries in which they take place.
The problem with looking at it worldwide is that the most expensive catastrophes happen in the richest countries. So, worldwide, the U.S., because of the wealth in the U.S., if you have a hurricane, the same size hurricane in the U.S. will cause far more cost than a storm, the same storm in China, for example. So simply because there's much more of value, there's much more wealth in the path of the storm.
Kopu is a good example of the math involved in natural disasters. When it hit the Philippines, it became the deadliest typhoon of 2015. Winds up to 210 kilometers per hour were recorded. Vast plains of rice fields were submerged by flooding due to rain and gigantic waves. 47 people died in the Philippines, 4 times more than in Mexico during Hurricane Patricia. Yet the cost of the damage in this developing country was 20 times lower than in North America, only $231 million. To understand the intensity of this typhoon, we need to look once again at El Nino, even though this anomaly concerns the East Pacific rather than the West.
Les eaux chaudes se déplacent
The
dans
warm
l'est,
water moves to the
mais elles restent
east,
chaudes à
but the
l'ouest.
water in the west stays warm.
C'est-à-dire qu'elles vont
So
rester à
this
des
water is going to stay warm
suffisamment
enough that
élevées
hurricanes can develop.
pour que des
In
ouragans
fact,
puissent se développer.
it's more like
Donc c'est
the
plutôt une
area is
extension de la zone des
extended
ouragans
during
auquel
an
on
El
assiste
Nino,
pendant un Nino
rather than the
qu'un
area
déplacement
moving.
de la zone.
The
Parce
zone
que
in
la
which
zone
hurricanes can
dans
develop
laquelle ces
spreads
ouragans
out,
peuvent naître s'étend.
so there are more
Donc il peut y en
hurricanes.
avoir plus.
El Nino is a phenomenon that matured in the second half of 2015, so it cannot be held responsible for the entire year's weather-related natural disasters. One of the most destructive cyclones was Pam, which battered Vanuatu before El Nino had even begun taking effect. Tropical islands surrounded by coral reefs and covered in lush vegetation, the islands of Vanuatu often top the list of the happiest places on Earth to live. Yet in March 2015, the country was struck by a natural disaster more devastating than any other in living memory. On the 6th of March, a pressure abnormality is detected north of Vanuatu, in line with the islands of Fiji. It's just a simple drop in pressure, but the weather services pay close attention.
Before we had satellites, we could miss cyclones. If a cyclone formed in the middle of the ocean and there was no boat to witness what was happening, we could miss it. But today, it's almost impossible to miss a cyclone. Then by inputting all the data into our models, we can predict its track, its life cycle, its intensity, and in general, we do a pretty good job.
For 3 days, the atmospheric pressure continues to fall. The water in the Pacific Ocean is warm, 26 degrees Celsius to a depth of 50 meters. This temperature anomaly can't be blamed on El Nino, since its effects are not yet perceptible at this time of the year.
For Pam, we can't talk about El Nino. It's more a question of global warming. Intense hurricanes have always existed, but don't happen often. Warmer air contains more humidity, so when it rains more, and when there's a hurricane, it rains a lot more.
If the water is at 26 degrees, 79 degrees Fahrenheit, and at the same time the atmosphere is also hot, it won't work. It needs to be warm at the bottom and cold up high. That's what is needed to make the atmosphere unstable and helps to create cyclones.
So what could have been a mere pressure incident becomes a tropical depression. Clouds gather, rain and winds pick up. The depression shapes into a cyclone and is named Pam. It continues on its journey to the south, heading straight for the islands of Vanuatu. Winds up to 250 kilometers an hour smash into the islands. The island's trees are bent and uprooted by the violence of the storm. Most of the houses are made of natural materials. Palm leaves, wooden beams, unable to resist the howling wind. Furniture, utensils, and tools are all swept away during the cyclone.
What happened was that the hurricane was extremely strong. You don't know many hurricanes of this intensity, because by definition they don't often happen.
Pam was a major cyclone, like we get every year. But the difference with Pam was that it hit populated areas when it was at maximum strength. Populated areas that are low-lying, and so very vulnerable to storm surge, and to rain and flooding.
Pam remains a maximum strength Category 5 hurricane for 36 hours. Then, after a night and day of terror for the population, Pam moves away, heading to the south of the Pacific Ocean and gradually losing strength.
A cyclone is a marine phenomenon. As soon as it touches land, its lifespan drops to a few hours, say 24 hours. It loses its energy, and in general it collapses pretty quickly. It's complicated because the islands of Vanuatu are small. Often with small islands, a hurricane can lose strength over land. Then it passes over the ocean and recharges with humidity, and it can become a very strong cyclone.
80% of the buildings are destroyed. Modern constructions are mostly spared. Everything else is flattened.
Inside, we were listening to the wind blowing, and suddenly, we see the roof of the house start to lift off. The wind pulled off the roofing and dropped it on the road. Over there. Then we saw the walls of the house collapse. All of a sudden.
Assistance is organized quickly with limited means and volunteer helpers like Peter.
There's about 4 or 5 of us to begin with on day 3, and then it's gone to about 100 plus volunteers, 30 odd trucks, 6 boats that have been getting out to the surrounding islands, getting out to these remote communities all around Taiwan and delivering aid, delivering medical checks. We've had chainsaw teams, we've had generated trucks going around charging people's phones, we've had the ambulances and the paramedics and the doctors going out to the surrounding islands and all around Taiwan. We're probably over 250,000 litres of water delivered since day 2, 3. We've had over 5 tonne of food. We've done hammer and nail kits delivered to communities to help people get their roofs and stuff back together.
Helicopters then take over. From above, it's easy to see the damage. Houses have lost their roofs, and the tropical trees, which usually keep their leaves all year round, are completely stripped bare. Everything has been ripped off by the cyclone.
There were movement on the ground. Most of them were waving white flags and trying to get my attention to come down. There was a couple of schools that had drawn big H's on their fields for help or helicopter.
Once the authorities establish contact with all the islands, they can determine the toll of the disaster. 16 dead and 132,000 people affected by this cyclone. Hospital personnel in Tana are still in shock, despite having prepared for several days prior to the storm.
The warning system was good, like quick. We had text messages on the phone, but many of us did prepare. We did prepare, but we still didn't expect a cyclone of that magnitude. I mean, the shutters on these windows you can see some still here. It's very strong. It's actually nailed, but just from all this vibration of the wind, so it just came off. Then later it smashed the louvers.
What is exceptional in Vanuatu is the speed with which help is organized. Resourceful and supportive, the inhabitants begin reconstruction without waiting for international aid. Light construction means easy rebuilding. As soon as the storm passes, construction begins on the islands.
Now we are rebuilding our houses. I made food. I asked my cousins to come and help me prepare the breeze blocks in order to rebuild our houses.
The rapid reconstruction cannot hide the serious long-term consequences. $500 million worth of damages, and looming sanitary problems that are a major concern for Michael Benjamin, in charge of first aid.
Today they're out on an island just off the coast of the Fate, and we're going to a village area that's got approximately 160 people that haven't seen a doctor as yet. So what they're generally finding is a lot of wound infections, a lot of gastrointestinal infections, a lot of respiratory infections, and what we're trying to do is assess them and treat them and keep them in their villages so that they don't need to go to the hospital. The local referral hospital here, Villa Central Hospital, is completely overrun. So the more people that we can keep in the villages and treat in the villages, the more we can keep out of a hospital and let it run efficiently.
The Vanuatu Islands need to rebuild quickly. Although they are not at the center of the Pacific cyclone zone, according to scientists, events like Pam could reoccur as a result of global warming.
In the future, the sea surface temperatures are likely to be even warmer, and the intensity of a storm is directly related to the temperature of the sea over which it passes. So that there are lots of studies on what we can expect, and the studies are not all consistent with each other. But overall, they tend to suggest we may have fewer storms, but the storms we have may be more intense.
What would happen if global warming combined with a strong El Nino? Would the effects of the two phenomena multiply? So far, scientists are unable to tell, but numerous studies are underway.
Le réchauffement climatique amplifie,
global warming amplifies, not just for El Nino, but for everything. The whole planet.
Les phénomènes
it amplifies existing natural phenomena.
Qui existent de façon naturelle. Là, c'est la conjonction
This is a combination of global warming
and
El Nino.
Où chaque année, ça se réchauffe un peu plus, et d'El Nino.
We have seen that El Nino affects a quarter of the surface of our planet. So when El Nino warms by 1 degree, the global temperature rises by 0.1 degrees.
When it comes to climatic disruption, there are other, more mysterious and less known events than El Nino and global warming. And this year, their impact was significant. One of the longest-lasting and most expensive natural disasters in 2015 took place in California, where a period of drought has been ongoing for several years. And this summer, the situation is dire. The landscape is scorched. Water levels are at their lowest point, and the sun keeps shining. A highly inflammable combination that rages through the region's forests. Every year, forest fires hit the southwestern states, but in 2015, they reach epic proportions. Fires start spontaneously in 4 different areas of California, as well as in Washington, Oregon, Utah, and Montana. As many as 30 fires burn simultaneously at the height of summer, mobilizing 11,000 firemen from all over the country.
It was dry before simply because you had blocking weather systems which were preventing the storms actually coming into California in the winter, because the rainfall in California is almost entirely in the winter, and actually over the last few years there's been the weather patterns have prevented the storms coming in.
The blame for the drought lies with a relatively unknown weather phenomena, Pacific Decadal Oscillation. It's characterized by abnormally cool surface waters in the Pacific, which push warm waters to the north and south.
El Nino, c'est un phénomène qui revient de manière épisodique tous les 2 à 7 ans. Là, on est sur des phénomènes qui oscillent à l'échelle de la dizaine d'années et qui apportent une anomalie de température positive le long des côtes de l'Amérique du Nord. Sur ce schéma, on voit les anomalies de température dans le nord du Pacifique, toute une zone d'anomalie, dont des anomalies très très fortes.
And we also have an anomaly on the coasts, which is a phenomenon on a much longer scale, on a scale over decades, which started at the beginning of 2014.
Et qui a commencé début 2014.
If the drought is caused by a large-scale climatic phenomenon, it's the combination of this and the El Nino which is developing.
The Pacific Decadal Oscillation has a cycle of around 20 to 30 years, and its interaction with El Nino is still not fully understood. Scientists can only state that these large-scale climatic occurrences sometimes combine, as they have in 2015.
En fait, c'est une bonne illustration à tous les endroits de la planète.
It's a good illustration all over the planet. There are these variations of different frequencies. There is the diurnal cycle, night and day, and then we have the weather, the seasons. And now we have El Nino. Everywhere on the planet there are these variations, which we're learning more and more about. We have, on one hand, global warming, which is ongoing, and on the other hand, California, with a Mediterranean-type climate and very little rainfall. The projection for the future is that if we don't do anything, there will be less and less water. On top of that, we can add this decadal variation with fairly warm water off the coast of California, which has been there for several years and which reduces rainfall in this area. And now we have El Nino, which, on the contrary, is going to bring more rain.
The Pacific Decadal Oscillation will continue for several years, but its repercussions will lessen as the effects of El Nino increase.
This winter, there's a prediction that actually it's going to be very wet in California, and maybe that will break the drought. It's not clear if even one wet winter will restore the water levels, but it's widely expected that it's going to be very wet in California this winter.
The damage caused by these forest fires is catastrophic. It's the worst dry season in the last decade in the United States. Fires have consumed 31,600 square kilometers of land in the Southwest, the equivalent of the entire state of Maryland, burnt to a crisp in a few months. 6 people, including 2 firemen, lost their lives. 17,000 residents had to be moved to avoid being trapped by the fires. Financial loss is estimated at $3 billion, a heavy toll even for these wealthy states. In recent history, the wrath of the skies has been relatively benign compared to that of the Earth. 2015 continues this trend. Hemmed in between India and China lies Nepal. A small mountainous country the size of the state of Iowa, but 10 times more populated. 30 million souls, mostly Hindus, live in this landlocked country, including 1 million in the capital, Kathmandu. Nepal is one of the 10 poorest countries in the world. A third of its population live in rural areas, at least 2 hours' walk from the nearest permanent road, and rely on natural resources and the cultivation of rice to survive. In the mountainous regions, there are few trees left to retain the stones that perch above the villages, bustling with small shops. According to the Hindu religion, the Nepalese people celebrate in their ancient temples the rhythm of the earth, an endless succession of periods of creation, preservation, and dissolution. Science backs them up. Geologists like Jan Klinger look back at Nepal's tectonic origins.
La tectonique des plaques dans cette région,
the tectonic plates in this region mean that India rises up at a speed of 4 centimeters per year. The plates that make up the Earth's crust are stuck. They become deformed over a time, and when the 2 plates move together, the upper plate, the Eurasian plate, deforms and creates chains of mountains. We squeeze the Earth's crust and create landforms. In fact, these 2 plates rub together. They're stuck. So while it's pushing behind, here it's stuck, and that builds up until the crust goes beyond its limit of resistance and releases, producing an earthquake, which allows the tension, the energy in the plates to be released, and this produces an earthquake.
The last major earthquake in Nepal was back in 1934 and reached 8.3 on the Richter scale. In 2014, Jan Klinger published a study that suggested that the 1934 event was a warning of another imminent earthquake at this fault line. History would prove him right. On the 25th of April 2015, a 7.9 magnitude earthquake hit Nepal. Nepal.
Je mets tant d'énergie dans le système.
If I put that much energy into the system, a 7 or 8 magnitude earthquake will release about the same amount. So today, where have we released? Which zones have been released? Which zones don't need to be released as much? By doing this work, we're able to pinpoint the zone that broke as one of the zones that was susceptible to breaking.
Jean-Louis Munier is also a geologist. He traveled to Nepal just after the earthquake to install GPS receivers that would measure any new movements of the ground.
Some areas of the Himalayas, like the area to the north of Kathmandu, rose up by almost a meter in the space of a minute, because the earthquake lasted for about a minute. In other areas, paradoxically, the Himalayas sank down. For instance, some of the highest summits in the Himalayas sank down slightly for a moment.
The number of deaths directly caused by the earthquake is estimated at over 8,000. Although geologists had foreseen the possibility of an earthquake, it was nonetheless impossible to predict its arrival with any precision.
La façon dont on a procédé, c'est effectivement de regarder les séismes historiques, essayer de comprendre la taille de ces séismes historiques, les séismes catastrophiques, donc de magnitude 8, plus des temps de retour qui sont probablement de plusieurs centaines d'années, pas loin de 700-800 ans pour ce qu'on en comprend. Mais par-dessus ça, vous venez rajouter des séismes qui casquent de façon partielle et qui, eux, reviennent par-dessus ce cycle.
Above the epicenter, stone villages are completely destroyed by the shockwave, killing hundreds of people. The survivors are left homeless.
Hello, my name is Kenji Galung. I'm 12 years old, and I've lost everything, my house and even my school.
When the earth shook, I was getting ready for the full moon festival. I was heating up some rice wine with myrrh that we call rakshi, just as I am now. Around me in the village, everything burned, everything collapsed. We were afraid of aftershocks, so we went into the fields. After the earthquake, we spent 3 days in the fields with the animals with nothing to eat. Luckily, friends from other villages arrived with clothes and food. Today we have nothing, but we still need to carry on living. Now we live up here in the fields in an encampment of tents that we built quickly using tarpaulins. But these are not our real houses. Tomorrow, we don't know where we will live.
The 2015 earthquake was a catastrophe for Nepal, but at the same time, it happened on a Saturday, on a beautiful day at the end of the morning. So the rural population was out in the fields, the children weren't at school, they were playing outside. So the destruction was not hugely catastrophic in terms of loss of human life. If the earthquake had happened in the middle of the night or when the children were at school, it would have been much more catastrophic.
In the following days, dozens of aftershocks continued to shake Nepal, including one strong tremor measuring a whopping 7.3 on the Richter scale. And then, another threat looms over the villages, the arrival of the monsoons. Heavy rains pound the stricken country. Water is inexorably drawn down into the earth. While it runs on the surface, it washes away the ground and turns roads to mud. But when the rainwater pours into the open wounds created by the earthquake, landslides are inevitable. And in Nepal, whole sides of mountains collapse.
So, just before the monsoon, the bowl has been shaken. So you have a number of slopes that are unstable, and when you add water to that, the ground gets heavier, and fissures are going to open up because you have put water in them. So you're going to create landslides that probably would have happened at some point, but over a longer period of time.
During the monsoon, you have a massive runoff from the Himalayas, several meters. There's a huge amount of water falling on the Himalayas, which creates small quakes. Little tremors that are nothing like the same magnitude as the major Himalayan earthquakes.
This village was literally swept away by a landslide and submerged under a flow of mud. 24 more victims are added to the number killed by the earthquake.
That was my house. The rain swept everything away. At 1 o'clock in the morning, it was raining really hard, and the land slipped. Then the landslide took down 13 houses. A group of 25 people tried to help someone whose house had been buried, but they couldn't get in.
There is no rest for the villagers. The monsoon season is the busiest time for farmers, tending the fields, the animals, and the crops that have survived. Further down the valley, Nepal's highly populated capital city was also severely shaken. Here, 1 million people live above the clay deposits left behind by a prehistoric lake. The seismic waves amplify as they cross the boundary between hard rock and soft ground. Traditional houses built of stone or brick are unable to survive the quake. Only recent constructions made of reinforced concrete still stand, and only where the steel is still holding the walls and floors together. Otherwise, the lower floors that support the weight of the building collapse.
If you go to Nepal, I just went afterwards. Not all the houses had fallen to the ground, far from it, but all the houses had been severely damaged and at the risk of collapsing. In any case, they are no longer habitable. They don't collapse during the earthquake, but they crack and break, and it just takes one slight thing to make them collapse.
In all, the earthquake caused 9,000 deaths and $10 billion of damage, half the country's gross domestic product, an exorbitant cost for Nepal. In order to find survivors, rescuers risk their lives. They excavate under floors that could collapse at any moment. By intervening quickly, emergency workers saved hundreds of lives.
It's extremely difficult to say it in words. I was standing outside my gate when it happened. And the first shake was from the west heading to the east. My gate was swinging at least 3 feet to the east and west because my wife, my kid, and my mother were inside the house. I tried to get inside. The gate was swinging so extensively, there was no way I could open the gate. The road outside is paved with small tiles. there was a rattling sound as if a huge serpent is going underneath your feet. I think it was one of the most scariest moments of my life, man. I thought, I'm dead.
According to Hindu belief, earthquakes are part of the third stage of nature's dance: creation, preservation, dissolution. Of all the natural disasters, earthquakes are the most difficult to predict. We know they are inevitable, but we have no way of predicting them.
In the case of volcanoes, we know that there are warning signs that we can measure. For example, small seismic events that are produced when magma rises into the chamber. But for earthquakes, we don't know what the precursor signs are.
One thing is certain. The measurements gathered by Jean-Louis Meunier's team show that part of the energy stored between the two tectonic plates has not yet been released.
Le séisme comme celui de cette année, il n'a pas tout donné,
ça on est déjà sûr,
parce que
we're sure about that because our studies show that one part shifted between the north of the mountains up to Kathmandu, but between Kathmandu and the plains, the overlapping part remains stuck.
Le chevauchement est resté bloqué.
So a second earthquake could relieve the tectonic strain with even more catastrophic results.
If we imagine that my hand represents the Indian plate, which is going under, here we have the mark showing the contact with the surface. So that's India, and that's what's underneath. And the earthquake that hit in 2015 was a fairly deep section. What still has to shift is this part that comes from the part that broke up to the surface. And that's another 100 kilometers. We could expect another major earthquake with extremely destructive consequences.
Whether it's a question of months or years, nobody knows. The scientific community will be keeping a close eye on Nepal, fearing that a second quake is probable. Despite this alarming collection of catastrophes, has the final toll of natural disasters for 2015 been exceptional? Not necessarily, at least in terms of economics, according to Robert Muir-Wood, who develops catastrophe models for insurance companies.
You can see what is the total cost worldwide of natural catastrophes. You can see by what the losses have been. It's probably around 100 billion euro of loss altogether. And it's of that kind of order. So there is a significant amount of potential economic impact of catastrophes out there, just on an average year. So I mean, I don't know what it is this year so far, but I mean, I think it's actually quite a lot lower than average. So in places like Taiwan, there's quite a lot of insurance. So there's been insurance losses this year. There's very little insurance in Nepal, for example, because it's such a poor country. So this year, for insurance terms, it's being very quiet.
Volcanologists agree with this analysis. At this stage, despite some spectacular events, 2015 has not been particularly newsworthy.
It was relatively calm. It was the Calbuco eruption. There was this Parlabunka that was dying out. So it gave, I think, the scientists a little bit of time to try to understand the data they had acquired. It's a very good year when there is not too much going on.
Finally, in terms of cyclones, the year 2015 has been geographically sporadic. Globally, the number of tropical cyclones has remained stable, with around 80 storm systems per year. For the Atlantic Ocean, 2015 was particularly calm if we refer to the alphabetical system that is used to name hurricanes as they appear.
Quand il y a un Nino,
When there is an El Nino, in other words, warm temperature anomalies in the east of the Pacific, cyclonic activity reduces in the Atlantic. For example, in 2005, a record-breaking year, we went all the way to Z, and then when we had used up all the letters, we started at Alpha, Beta, Gamma, Delta. And I think we were up to 31 named cyclones in 2005, which is an all-time record, because normally we have about 10 in the North Atlantic, so that gives you an idea. Today, we're at J. In 2005, we had to start using Greek letters.
This apparent calm does not mean that scientists can lower their guard. The El Nino effect is far from over. It is not until Christmas 2015 that El Nino, named after the baby Jesus, reaches its full potential.
It's quite normal that we haven't yet seen any very dramatic climatic anomalies on a global scale. El Nino is still growing, and it won't be at its maximum until Christmas. At the beginning of 2015, we had a very weak temperature anomaly in the Pacific Ocean, and the growth period is only beginning now.
The potential consequences of El Nino will not be limited to the Pacific. This meteorological system is one of the most powerful forces that affects global climate.
It's not at all as localized as it seems from a European point of view. At the tropics, we have half the surface of the world that is located between 30 degrees north and 30 degrees south. And the Pacific Ocean is a real monster in terms of the world's oceans, because we have 17,000 kilometers of coast from South America to the Philippines at the other side.
Torrential rainfall, droughts, serious disruption could affect our planet in the upcoming months. Even thousands of kilometers from the area where the climatic abnormality began.
There'll be huge amounts of flooding along the coast of Peru and Bolivia, for example. There may be a drought in the northern part or the northeastern part of Brazil. So there are a lot of things which correlate very clearly with what happens when we have an El Nino. I mean, I think you tend to get a drought in Australia, for example. There are many things we can actually link to El Nino, many things we can expect to happen over the next few months.
The last record-breaking El Nino was in 1997-98, with a temperature rise of 2.7 degrees Celsius. The damage caused as a result was estimated at $33 billion. By the end of 2015, El Nino is already close to a 3-degree rise, allowing climatologists a glimpse into future major weather trends.
There's no doubt that 2015 and 16 will be record-breaking years in terms of heat. But on the other hand, 2017 will be a cold year, because after El Nino, there will be La Niña, which is a cooling down of the Pacific, so it swings back. But in terms of heat waves, if we look at heat waves in France, we're fairly sure that if we don't reduce current global warming, we will have more heat waves. At the moment, we have 2 or 3 days of heat waves per year in France. But in the future, we expect to have up to 20 or 30 days of heat waves per year. We're pretty sure of that. In terms of storms and precipitation, the research isn't advanced enough to say anything definite yet.
This scenario is still reversible, on the condition that major political decisions are made to limit the level of greenhouse gases and to keep global warming in check. Despite a large number of natural disasters, 2015 has not been as unusual as we might imagine. Certain unexpected events, like the earthquake in Nepal, left deep wounds. Others, such as volcanic events that are easier to study, have more or less remained under control. In 2015, all the ingredients for an explosive year came together. A record-breaking El Nino, global warming, and the Pacific Decadal Oscillation combined to create extreme weather events. And it's not over yet. The dice are loaded. We can expect more severe weather patterns in 2016.